Hello everyone, and thank you for coming today and see us at these first Ally Global Tech Talks. My name is Oscar Garcia. I am CTO from Ally Global and Microsoft Regional Director as well. And here with me I have
Diego Zacarias, Technical Lead from Ally Global Technology Services.
Excellent. Thank you for coming for us today.
Thank you for
Diego.
the space.
Absolutely. It's very exciting as you know, technology has changed the world, and in a world today where pandemic is a fact of life, we need to talk a little bit about how's resiliency. But we talk about resiliency on the business, and when we talk about the business, there is some technology behind it that help us to do resiliency, right, Diego?
For sure.
So what is resiliency? Let us know about resiliency technology.
Let's start with the concept, and for that I want to share with you the following quote. Resilience is not about avoiding failure. It's about handle the situation and have a path for return a fully functional state quickly as possible.
Kind of like what they do with the world, right? Like in Ally Global, when we needed to do the change and the pandemic ran in, we really needed to be resilient. So we did whatever we could to keep the lights on, and we did effectively. But in the business as well, technology is as important as that piece, right? Excellent. Okay. So let me tell you. Let me ask you about this. Now that you saw about resiliency, what is we talk about the business world in case like we did resiliency on our business, but in technology, how do you use that in the real business world?
Okay, we live surrounded by services that are talking to each other all the time, and those of services may be down and can be have third-party services. We don't have power there. And for that, we have to implement some patterns for resiliency.
Okay, so what do we know about Azure? What does Azure and any other, I'm assuming other cloud providers as well does it, but you said a little bit like Amazon or Google does some things, but you saw about Azure. What are you sharing us with Azure in terms of those?
Yeah, Azure has a cloud-native resilience, and some of their services like Cosmos DB, Redis cache service, both service and SQL database, they have a configurable pattern to wait and retry policies. So
there is, let me interrupt you there because I was curious when you mentioned that. So there are certain patterns that you can implement, right?
For sure.
What kind of patterns? I'm guessing you're bringing some of those patterns here today with us.
Yeah, we have the timeout. Basically, is just the policy is not wait forever because the time is expensive and we are wasting resources and the user time. So the policy for the timeout is not wait forever. Or the other pattern will be the wait and retry. So basically, we can have a package loss, for example, and some point in the communication, we lost the communication. So we can wait and retry again to make a successful request. So this is the concept behind the wait and retry. We have another pattern that will be the circuit breaker. The circuit breaker is a little bit more complex because it's a state machine. It have a closed state and everything goes as normal. But when we have a failure, the threshold, when the threshold is met, it will change to open state. And the next request will be sent to can be handled gracefully without wasting time, because the next request will be in error right away. And then we have a middle state that will be the half open. So sometimes we'll try to do a actual request, and if it's a successful request, we'll change again to the open state, closed state, and everything goes normal.
So it's very interesting, right? Because those patterns, I mean, it's everybody think like just having Azure, which is a great platform. Any of those clouds out there have a lot of power, and they will do it by themselves. But like in Austin Technology Services, right? We are really experts on doing this. So what that means is like you are providing those patterns, right? And we need to implement So our systems, like we see here, our systems get that resiliency that our customers are looking for. Correct?
Yeah, and we can combine those patterns because they don't work alone. So the other pattern that I forgot to mention is the fallback. The fallback is when, for example, when the timeout comes in, the fallback will comes in to rescue for that request and have something to respond to the user. So basically, it's a funny situation because the last week we implement the fallback service with one of our clients. So they have an API that is calling to another services, and for some reason sometimes fail. And it's a compliance thing with that portal.
Interesting.
So they want to see how it looks like the data when the user visits the site. So if it fails, how to,
back from it.
Yeah,
Absolutely.
So we did a fallback service for that, and so when the service fails, the fallback comes in and rescue the request, and we don't have complaints anymore.
See, that's what I love. Our engineers like you, really solving issues in the real world. That's our technology service is all about. That's what we have the Tech Talks to show exactly what we do. So I guess it's a lot of the talking, but we really need to get into the grits and needs, right?
Yeah, for sure.
So we need to go down to some of the demos. All right. So why don't we go some demos? Do you have some demos that are ready?
Yeah, for sure. I have
Excellent.
a demo to test each pattern that we talk about. So let's go and let's dive to the code.
Okay.
So basically, we have three projects. I have a demo client that will be just to represent the client. It's a console project.
Okay.
And we have also a principal service that will the service that has implemented those patterns. And we have a third-party services that will be the faulty one. So the faulty one has three endpoints. Basically, a delayed endpoint. The delayed one will have randomly delay between 0.5 seconds to 5 seconds. Otherwise, will respond immediately. The next endpoint will be a faulty one. The faulty one will be randomly fail, and after the first fail, it will be down for the next 5 seconds.
Okay.
And the third one will be the delayed and faulty one. So it's a combination of the first two.
Okay.
And we'll have the delay after. It will have randomly have a delay for 50 seconds. Will be down for 50 seconds, and when we're done, it will have a delay before to respond that has an error. So it's time, it's pressure time, and we have to take care of that. Perfect. So the first will be the timeout without the policy.
Okay.
So let's start with the actual action. So here in the console, I have the okay. So here is so. When the request takes more than 2 seconds, it will highlighted with red. And if it's under the 2 seconds, will be green. So we can see how at this moment,
I just had a question there. Sorry to interrupt. Is that being shared with the audience? Because I don't know if it's just sharing the screen with for the Visual Studio, or do you have the full screen being shared?
The full screen.
Oh, excellent. Perfect. I didn't want to miss anything from our customers,
Yeah, we are showing the code, the actual code. We can share the repo also.
Excellent. Yeah, let's do that also.
Yeah. So basically, we have a lot of requests, and some of them, they took more than 2 seconds. And
correct.
So let's go to see how it looks like with the policy. And with the policy, looks like this. The same, but we are the don't wait forever. So when a request took more than 2 seconds, it will cut the request and notify to make another action, maybe a fallback service or a cache or response from a cache service, anything else. So, but we have to notify gracefully to the user.
Right.
Okay, so the next one will be the wait and retry. The wait and retry, let's go to without the policy. The wait and retry is using the faulty one. So it's going to randomly fail, and after that will be 5 seconds down. So right now we can see that there is a 4 requests failed, and we have a lot of complaints there, right? So let's see how it looks like when we have the policy in place. So here we are showing also the requests from the service. So we are getting all the requests successfully completed, because when fails, it will wait and retry until we have a successful.
Which is very resilient. Because, I mean, sometimes it's error that goes into the network or something, so you just have to wait. You don't have to give the answer to the user right away. It's not working because it's, I mean, it might be something that is environmental rather than the application itself.
Yeah, and like we said before, we can combine those policies, so we have many options for a start from there. So you can see there is any request, all the requests are completed successfully. So let's see with the circuit parent that will be using the combination of the two. The first two, it will be a delayed and faulty one. So let's see how it looks like without the policy.
It makes the, makes the audience a little anxious about see how things really work in the real world and how do we implement it in technology services. Perfect.
Yeah. For example, we are wasting time and we have a request failed after 5 seconds and another request failed after 3 seconds, and we are getting a lot of requests failed, and we are working as normal, but suddenly we have another request failed, and from there will be 50 seconds down. So we are lost. We are lost with the time. So let's see how it looks like with the policy.
So basically, we're making it fail at the beginning, and then we implement the policy, which implements the patterns that we're looking for. That's kind of like how do things look in the real world and people can implement it. You will get this information, by the way, for the audience. You will get it in a repo. We're going to publish this publicly in a Lilac Global repo. Once we get this up there, we'll send with the video, you will see a link to that repo. All right.
For sure. So let's see how it looks like when we have the circuit breaker in place. So here, the first request failed. The second failed, but the next one will be showing us the circuit is open. So we are notifying to the user right away that we have an issue. So we can do gracefully or combine with a fallback service, like I said before, but we have the power to control the state and the flow of the data. So here in the second, we can see how it looks like when it's trying to pass from the open state to the half open state, and then return to the closed circuit. So this is awesome, and some of the companies, they have their own tools to inject those issues in production.
And why do they do that? That's interesting to know.
There is a chaos engineering. So it's basically a set of patterns to inject errors in production. For example, Netflix has a tool that is called Monkey Chaos. So randomly turns off virtual machines or turn down containers to force the developers to build application with resiliency. So it's pretty amazing because you are talking to inject issues in production, not in QA stage or something like that. It's in production, so.
And that's right,
it's the real world.
It's the real world, and I think you make a good point there when showing that kind of information, because like for us in our security operation centers or in any of the monitor centers that we have or support that we do, we have to also manage and be aware of the issues that happen in production for our customers. So something like that happens, and we proactively are looking for this. We can see also, and that's kind of what we do, is we can see also that our response team, our service desk, our managed service, whatever we have up there, step up to the plate to see what's going on and get back to our developers. Excellent.
For sure.
Okay, so I'm guessing, do we have anything else, or are we good? I think we're good, right?
We're good, and definitely we can share this repo to maybe.
All right. I appreciate it very much, Diego. Thank you for your time today. Thank you for the honest today to listen to us. We will definitely put this repo up in the GitHub in our public repository, so you guys can download it and play a little bit with it. And of course, all that information will be in the video as a close-up for this one, where you can reach us or reach Diego at any time at allyglobal.com. Thank you so much for watching today, and thank you for being part of the Technology Services.